Hello class and welcome back. This is talk number 4. We're going to look at the regenerative circuit in hydraulics. This is revision for you. On this circuit it's a normal operation. So we have some identifiable component parts. This lower part would be classed as the power pack. We have the tank containing the oil, a suction line filter, the pump and motor which generates the flow of oil. We have a pressure relief valve that we can adjust and we can maintain a certain pressure in the system. This pressure is applied to a 4-port 2-position valve, and in this case it is solenoid operated both sides. The drawing shows that the flow is going into the cylinder and causing the double acting cylinder to be in the retracted position. Of course, if we applied an energised solenoid number 1, the valve would go across and oil would go up, through, into this side of the cylinder, and this cylinder would go forwards. Of course, the oil here would come down, go through and return to tank. This small symbol of the tank is really the return line going back to the main tank. Okay, but hydraulics is quite clever because on this circuit number 2, I've connected the pressure to both sides of the cylinder. And one might think, what would happen to the cylinder? Well, the cylinder goes forward and it goes forwards very well. This is due to the fact that force is equal to pressure times area. So the force induced on the forward stroke would be the pressure times by the cross-sectional area of the piston. And that would cause the force, which I'll have here as force. However, the pressure is also going into the front end of the cylinder. But the cross-sectional area is smaller due to the fact that some has been removed by the piston rod. Therefore, with a smaller area, there'll be a smaller force induced. So the return is a smaller F, we'll say. It's a smaller force. But the greater force can overcome the smaller force, and it will push the cylinder forwards. The trick here, and the clever part, is that the oil will intensify to a degree. It will not be able to go against the pump flow, so it will assist the pump and it will also feed into that side of the piston. Therefore, the volume here is filled much quicker. So the regenerative cylinder goes forward very, very fast as a comparison to the normal operation. Now that's okay because the speed is of great benefit, but you have lost force because you've always got a smaller force pushing it backwards. So the technique would be maybe to use the regenerative up to the forward stroke and then change to the normal operation to go back to the maximum force. Now I've redrawn this very slightly because I've put it into perspective. I've used a 3-port 2-position valve, solenoid operated, and I've used this to give the regenerative with a bit of control. So at the moment the pressure is going to a blank position. The flow directly from the pump is going into the front end of the cylinder. The back end of the cylinder is going to tank. So this cylinder now, this piston will be retracted. The cylinder will go into its negative retracted stroke. However, if I applied an energised solenoid number 1, the valve would go across, oil would go up, through, into this part of the cylinder, but of course at the same time it will also be supplying the front end. So I've now linked the two together and it will go forwards quickly as a regenerative cycle. But again, with the sprung return on the valve, when I do not energise solenoid number 1, it will go back to the drawn position and it will cause the cylinder to retract. So what you need to think about is this. If you have a normal operation cylinder and system, as is exactly the same as the one drawn here, how do we introduce this type of valve into this system so we can have normal operation when you want normal operation, but when you need the regenerative for the fast speed operation, you can call that forward as well? Well, I'll draw this valve in a position. It's not the best position, but it probably makes sense. So I'll draw that valve here. So what I can do, I'll put the solenoid, a small solenoid on there as well, and I'm going to connect this time that line into there. So it's blank at this moment, but I will also break this line, this tube, and I will connect into here, into there, and into there. So what we have at the moment is this. If I energise solenoid number 1, the 4-port 2-position valve would go across, or it would go in, up, through. This is blank, so it would continue en route into that side of the cylinder. The front end of the cylinder is coming through and back and down to tank, so it would go forwards normally. And of course, when I applied an energised solenoid 2, it would return. The oil would go through, send the cylinder back, and it would go through into tank. So I can use this as a conventional normal cylinder if I do not apply and energise that solenoid. I'll just put a spring return on there as well. But this is the point. If I changed this valve over and applied a solenoid here, I'll call that solenoid number 3. If I applied and energised that solenoid, this oil, this line would connect from here through diagonally to there, and this blank section would go across and blank this line. So now what we would have a connection all the way through on this side. It's already connected here, so when I apply an energised solenoid 1, the oil would go up, would go through, and it would supply both sides simultaneously. It would cause the cylinder to go forwards fast as a regenerative cycle, and then when I stopped and did not apply a signal to this solenoid, I de-energised that solenoid, it would return to this position, and when it returns to this position, I am then immediately back to normal operation, so it would then go to the high force requirement. It's a way of connecting the two together. I guess I could do this another way for you as well. So let's look at this, doing this another way. I'll just remove the valve again, and I'll reconnect this together so it's visually as you saw. I'll draw the valve this side of the circuit. So this time I could maybe change the circuit design slightly. I could connect this into the circuit, so I've now connected that as a full connection through. And I could take a supply from and directly from the pump into that valve. Now at this stage, this is connected through, this is blank from the pump, and therefore as I operate solenoid 1 and 2, the cylinder will move backwards and forwards in normal operation. However, if I energised, and we'll call solenoid 3 this side, and we'll call solenoid 4 that side, if I energised this solenoid and sent the valve across, imagine this, that blank section would blank that line, but this connection from the pump would go through, out and into this line, and I've reconnected this through. So at this stage now I've made what would be a connection directly with pressure to that side, and when I energise solenoid 1, it would cause this line to connect, and I'm now going to go for regenerative. So I can easily do this. I can apply solenoid 3 and then solenoid 1 and 2 for normal operations, or I can apply solenoid 4, change the valve, and then use solenoid 1 in this case to cause regenerative forward stroke. So these are two methods. There are many methods, but I want you to think about the regenerative cycle, think about the normal cycle, and think about how you can combine to have both if you require both. Thank you very much. Goodbye.